us look at this example. Find the points at which fx equals to x cubed plus 2x has horizontal tangent. Do you know what is the meaning of horizontal tangent? I mean, what will be happen if the tangent is horizontal line for a curve? Okay, so for example, so look at this curve. This curve is like, let's suppose there is a curve, and then suppose at that point the tangent is horizontal, right? When the tangent is horizontal, then the slope is 0. You see that? Slope is 0 meaning the derivative is 0. So we want to find out the points where the derivative is 0. Okay? So to do that, so what we do here is, so find out f prime of x. What is f prime of x? Find the derivative of x cubed. X cubed is 3x to the 2, right? 3 minus 1 plus 2 times derivative of x is 1, right? So it is basically 3x squared plus 2. So you tell me the values of x that makes this 0. So none of the values of x will give the derivative 0 here, right? So none of the values of x will give you the derivative 0, because any positive or negative value of x gives the x squared positive times 3 is positive plus 2 is positive, right? So there is no point where tangent to fx is horizontal. So that point does not exist for this problem, because there is no point where the first derivative is 0. Okay, so we are looking for the values of x where the first derivative is 0, but when you set that equals to 0, you don't get values of x. You will get imaginary values of x. You see what I'm talking about? So it looks like this. If you set that equals to 0, you will get 2x squared equals to negative 2, right? Sorry, 3x squared equals to negative 2, right? If you solve that, x squared is negative 2/3. So x will be plus minus root 2 over 3i, right? This is not a real number. So we were trying to find out the point where x is where the derivative is 0 for that x. Okay, but we did not find the real number where that makes derivative 0. So there is no point where the tangent to fx is horizontal. Okay, let us look at another example. Find the points of horizontal tangency for fx equals to x plus 2 cosine x. Again the same thing. We are looking for the values of x where the first derivative is 0. Okay, solution. Let's find out the first derivative. So f prime of x equals to how much? 1. The derivative of x is 1 plus derivative of 2 cosine x is 2, and then minus sine x, right? Because the derivative of cosine x is then you can write this as a 1 and then minus. So you see that 1 minus 2 sine x, right? Now for horizontal tangency, if you want to have a tangent horizontal tangency, you need to have f prime of x must be 0. That means 1 minus 2 sine x must be 0, right? So how do I solve that? You add 2 sine x on both sides. You will get 1 equals to 2 sine x, right? So divide by 2 on both sides. You get, this implies sine x equals to 1/2. So what are the values of sine x? So what are the values of x so that sine x is 1/2? Or you can take the inverse sine on both sides. You will get sine pi over 6 is one value, and the sine 5 pi over 6 is the another value that gives you 1/2 for sine, right? So this is also 1/2, this is also 1/2. There are so many other values, but we are looking only that lies between 0 and 2 pi only. Okay, so what do you get then? So if you take this one and that one, they will get x is, you cancel sine and sine, or you take this inverse sine, you get x equals to pi over 6. So you get x equals to pi over 6, and the another value is, if you cancel sine and sine here, you will get x equals to 5 pi over 6. Okay, now the question is asking to find out the points for the horizontal tangency. We got the x values, we need to find out the y values. So how do I find out that? Is at x equals to pi over 6. Okay, so how do I find out y? Y is, you just plug in this is y value, right? So y equals to x plus 2 cosine x. So it will be pi over 6 plus 2 cosine pi over 6, right? If you simplify that, what do you get? Pi over 6 plus 2 times cosine pi over 6 is root 3 over 2, right? You cancel 2 and 2, so you get pi over 6 plus root 3. Pi over 6 plus root 3. This is what you get. And similarly, if you plug in the values, if you take x equals to 5 pi over 6, x equals to 5 pi over 6, then y will be 5 pi over 6 plus 2 cosine 5 pi over 6. So if you use the, what is the value of cosine 5 pi over 6? That is negative root 3 over 2, right? So that is 5 pi over 6 plus 2 times negative root 3 over 2. And if you cancel that 2 and 2, what do you get? You get negative 3, right? So 5 pi over 6 minus root 3. So what are the points then? The points will be, if you take x equals to pi over 6, so the points are, one is pi over 6 plus comma pi over 6. Pi over 6 is x value, right? And then comma pi over 6 plus root 3. Pi over 6 plus root 3. This is one value. The other value is 5 pi over 6 comma 5 pi over 6 minus root 3. This is how you get the points of horizontal tangency. Okay. So the next question, next example is, find the value of k such that fx equals to k root x has tangent line y equals to 4x plus 36. The curve is y equals to k root x is given, and there is a point somewhere that this is tangent line. Okay, so the tangent line has equation y equals to 4x plus 36, that's given, right? From this graph you can say that if this line is tangent to this curve, then they must have the same y value, right? Because their x value and y value, the point xy is common to both. The point xy is common to both this curve and this line, right? And also their slope must be the same. So how do I do that? Is you can say that y must be equal to y, right? Same y values will imply k root x equals to 4x plus 36. This is, let's write down, this is equation 1. And then another thing is same slope. If you have the same slope, then you find out y prime equals to y prime, right? Y prime equals to y prime. This is for the curve, this is for the line. Okay, what is the derivative of kx, k root x? Let me show you that. What is the derivative of k root x prime? That is k times x to the 1/2 prime, right? That is k, you can pull that out. The derivative of x to the 1/2 is 1/2 times x to the 1/2 minus 1, right? That will be k times 1/2 x to the negative 1/2, right? Because 1/2 minus 1 is negative 1/2. You can move that to the bottom, so it is k over 2x to the 1/2, right? So you can write k over 2 root x. That is the derivative of that the curve, right? So you can write k over 2 root under x equals to the derivative of y prime for the line on the right side is basically 4. You see that? So what do you get from here? You multiply both sides by 2 root x. Multiply by 2 root, let me use different color for that. So multiply both sides by times 2 root x times 2 root x. Then you cancel that, so you get k equals to, you get basically k equals to 8 root x, because 4 times 2 root x, right? And what you do is use it in 1. If you use that k value in the 1, what do you get? You get 8 root x, that is k times root x. I'm just plugging in here that k value, okay? Equals to, what do you get? So if you do that, that equals to 4x plus 36, right? So it is 8x equals to 4x plus 36. You see that? So subtract 4x, you will get the x value. Okay, you get 4x equals to 36. You see that? So what do you get then? X is 9, right? If you divide by 4 on both sides, you will get x equals to 9. But you are asked to find out the k value though, right? So what is k then? K is 8 root x, right? So therefore, k equals to 8 root x, right? So you see that? So what is the x though? X is 9, so equals to 8 root 9. So that will give you 8 times 3. Root 9 is 3, right? So that will be 24. That is the value of k. You see that? So that value of k will give you that this is the tangent line to that curve. What is the point though? If you are asked to find out the point, that will be the x equals to 9 and y will be 3 times k is how much? K is 24. So 24 times 3 will be 72. 9 comma 72 would be the point. But here you are asked to find out k, so you don't have to find out the point there, okay? So the next we will see some more examples there. Okay, before we do some more example, let me give you some of the definitions, okay? So we said that the derivative is used to find out the slope of a function, right? Also, the derivative can be used to find out the velocity of a moving object, okay? If an object is moving in a straight line, how do I find out the velocity of that object at a certain time point? Also, if an object is falling freely from a certain height, how do I find out the velocity of the object or height of that object at any time point, okay? So all those kind of application, we can use the derivative. Okay, so let us look at this first formula or the first fact. Instantaneous rate of change, in other words, we call velocity at time t. Let st be the position function for a moving object along a straight line. Then the velocity or instantaneous rate of change is s prime of t. If you find out the derivative of that position function, that will give you the velocity function at any time t, okay? Also, the average velocity in an interval a comma b is given by, we also call average rate of change, s at b minus s at a divided by b minus a. That is the formula we use, okay? And if you are throwing certain object from a certain height h0, you are throwing up with the velocity v0, then that object will go in the highest point and then it starts to fall down and it hits the ground, right? So that phenomenon we can model by st, this is the position function, is equals to -1/2 gt squared plus v0 times t plus h0. h0 is the initial height, v0 is the initial velocity, and g is the acceleration due to gravity. That is, the value of g is 32 feet per second square, or g is 9.8 meter per second square. These are the values we use in the different measurement system, okay? So let us do some examples here. So for this one, let us look at this example on the use of this formula, okay? For an object moving on a straight line, the position function is given by this. St is given by 6t squared minus 1. You want to find out the velocity at t equals to 3. So how do I find out the velocity from the position function? It is just the derivative, right? So let's find out the s prime of t is how much? 6 times twice t minus 0, right? Because the derivative of, to find out the derivative of 6t squared, 6 is a constant. You can pull that out and you find out the derivative of t squared only. So the derivative of t squared is 2t 2 minus 1 to the power 2 minus 1. That is 6 times 2t, that is 12t. Minus 0 is just 12t, right? But you need to find out at t equals to 3. So at t equals to 3, s prime of t, you can denote by vt, that's the velocity, right? Is equals to 12 times 3, that is 36 feet per second, right? Unit per second. So feet per second, if it is given as in terms of feet. Okay, that's the answer. Next, find the average velocity. So how do I find out the average velocity? So the average velocity is equals to s at 3.1 minus s at 3 divided by 3.1 minus 3, because this is like A, this is like B, right? So you are trying to find out the velocity in this tiny interval 3 to 3.1. So what do you get if you do that? So just plug in that 3.1 and then 3 there, okay? So that will be, if I plug in 3.1 for t here, so it is 6 times 3.1 squared minus 1. So to find out s at 3.1, what you do is, this is the s function, right? So that is the s function, this is the s function, okay? And you plug in t equals to 3.1. What do you get? If you plug in t equals 3.1, you will get 56.66, and then minus, plug in s equals to 3. What do you get? You will get 53. Just plug in 6 times 3 squared minus 1 and divide by 3.1 minus 3 is 0.1, right? So what do you get? This is 30, so 56.66 minus 53 is 3.66 divided by 0.1, right? That is basically 36.6. So this is the average velocity, so feet per second or whatever unit there is, right? So feet per second, you can write feet per second, okay? See, what is the difference between this value and that value? This is almost, they are almost the same, right? The reason why they are almost the same is, so here it is instantaneous velocity. It is trying to calculate the velocity at t equals to 3, but it is trying to find out the velocity, average velocity, the average of the velocity in that interval 3 and 3.1, okay? So this is the average, this is the velocity at 3, this is the velocity in that interval. So that's why, since this interval is very small, that's why these two values are almost the same, okay? So we will see, a ball is thrown upward from a height of 6 feet. What is happening there is, there is 6 feet height, right? There is a ball, it is thrown upward with a velocity of 30 feet per second, 30 feet per second, okay? And then what is the velocity after 3 seconds? So you want to find out the velocity after 3 seconds. So first of all, you will find out the position function, and then you will find out the derivative of that position function, okay? And then it will go up, and then it will start to fall down, right? That's what it is happening when you throw a ball from a certain height. Okay, so what is given? So h0 is given as 6, and v0 is given as the initial velocity is 30 feet per second, right? So how do I find out? And then also g, the acceleration due to gravity, is given as 32 feet per second square, right? So s of t is given as -1/2. I'm just using that formula, right? And then times 32 times t square, and then plus v0 is 30 times t, and then plus what is h0? H0 is 6, right? So how much you got? That -16t square, right? And then plus 30t plus 6. This is the position function. If you want to know the position or the where was the ball after 3 seconds, then you just plug in that 3 here. But the question is asking, what is the velocity after 3 seconds? So you need to find out the velocity. So s prime of t is, you find out the derivative of that, -16 times 2t, because the derivative of t squared is 2t, plus 30 times derivative of t is 1, right? So that is basically -32t plus 30. But you want to find out the velocity after t equals to 3. So you'll get s prime at 3 is equals to -32 times 3 plus 30. I got, this is that 32 times 3 is 96. -96 plus 30 is -66 feet per second. That means the velocity is negative, means the upward velocity is positive, so the downward velocity is negative, meaning that it is falling down. It is not on the climbing up, it is not ascending, it is in the descending position. It is somewhere here, okay? That came somewhere here. That velocity of that object at that time is -66 feet per second, okay? So this is the final answer for this problem. Thank you, guys.